Hello, I'm Tim Gearhart with Hisco Incorporated, here today to talk to you about 3M EMC Solutions and the new EMC Solutions Kit brought to you by Hisco Incorporated. Hisco Incorporated has partnered with 3M to provide a new Electromagnetic Compatibility Solutions Kit designed to test, evaluate, and provide training on EMC technologies. The kit is targeted to design engineers and EMC engineers at electronic OEM manufacturers and accredited labs that test devices and equipment to ensure they meet regulatory requirements. The vertically integrated EMC Solutions Kit is the first product on the market that combines diagnostic instrumentation, materials from multiple 3M divisions, and engineering solutions from Precision Converting, Hisco's custom fabrication division. Included in the kit is information regarding Hisco's product offering and Precision Converting, our custom fabrication division. The EMC Solutions Kit product flyer identifies materials and instrumentation that's included in the kit. There's product information made available regarding 3M EMC instrumentation, including noise and comb generators, diagnostic tools, antennas, and test cells. Product information regarding 3M's foils, absorbers, and fabrics made available for EMC solutions and protection. Some educational guides regarding product selection of materials for applications to help your design and test engineers evaluate materials. Sample sheets of popular products, including tech sheets to help identify materials for your applications. The EMC Training Kit Manual, which identifies experiments using the near-field probes and test board to help educate your design engineers on proper function and use of the equipment. The E-field and H-field probes themselves and the test board, as well as a sample die cut kit to identify applications for die cutting. Included in the kit are the near-field probes for E-field and H-field, along with a test board. The probes are marked accordingly. The proper way to hold the EMC probe is in your right hand. Just hold as you would a pen. Press the red operate button with your thumb and keep it down for the duration of each test. Adjust the level dial with your index finger. To zero in on the exact source of emission, gradually reduce the sensitivity of the probe by slowly turning the level dial toward the lower numbers. Experiment number 1. Observe that ferrite suppresses high-frequency signals. Ferrites introduce losses for high-frequency signals by converting current into heat. Ferrite filters are used to reduce high-frequency content of the signals. In this experiment, we will observe the behavior of the ferrite filter and will quantify its performance. Step 1. While holding the tip of the EMC probe over the trace leading into the ferrite as shown, adjust the level dial to the green LED. This is the signal after the ferrite. Move the tip of the probe to the trace on the other side of the ferrite. Do not readjust the level dial. Now more LEDs are lit. This is the signal before the ferrite. Conclusion. Observe the change in pitch of the sound and in the LED graph as you move the probe. The signal is much weaker after it is attenuated by the ferrite. Experiment number 2. Identify sources of E-field and H-field. Electric field is generated by presence of voltage in wires and magnetic field is produced by the current. In absence of current, there is no magnetic field. Step 1. Bring the tip of the E-field probe to the top of the 9-pin D connector. Observe high level of E-field emissions coming from the connector. Step 2. Do the same test with the H-field probe. Observe that there is very little or no H-field registered. There is no current coming through the 9-pin connector, therefore it generates just electric field, but no magnetic field. Conclusion. One needs to use both E and H field probes in order not to miss emission sources. Experiment number 3. Locate the trace with the high frequency current. Magnetic field is highly directional. Its direction correlates with the orientation of the current in wire or trace. Step 1. Place the tip of the H-field probe over the traces of the demo fixture as shown, and slide the tip across the traces, keeping the seam of the tip in line with the traces. The seam indicates the orientation of the probe's sensor. The highest pitch of the sound and the most LEDs that are lit indicate the trace with the high frequency current. Try to follow that trace. Step 2. Rotate the H-field probe around its longest axis to demonstrate the directional characteristics of the magnetic field. Now the probe sensor is perpendicular to the direction of the current, and the probe indicates almost no magnetic field. Conclusion: a magnetic field is directional. The H-field probe will clearly indicate the trace with the high frequency current when the probe sensor is in line with the trace, barely registers the field when the probe sensor is perpendicular to the current. Experiment number 4. Verify efficiency of shielding and absorbing materials. Shielding and absorbing materials block electromagnetic waves and reduce electromagnetic emissions. Varying material types react differently depending upon application. Here we will show the value of the EMC Solutions Kit by introducing a selection of materials and demonstrating their effectiveness. Please choose for this experiment various sample sheets or sample die-cut parts provided in the kit. This will help identify which material type will be most effective per application to a design or EMC engineer. Please use the H-field probe for this experiment. Slide the H-field probe across the traces, keeping the seam of the tip in line with the traces. Find the area on the board with the highest pitch sound and most LEDs lit. This is the problem area of the board. To eliminate this problem, let's try several materials to identify the best solution. This material is not effective. This material is effective. This material is not effective. This material is effective. Conclusion: shielding and absorbing materials reduce emission levels. For a design engineer or EMC engineer to quantify attenuation introduced by the shielding or absorbing material, please connect the probes to a spectrum analyzer, oscilloscope, multimeter, or 3M ground probe. Experiment number 5. Locate current in the ground plane. The demo fixture has a very small ground plane. However, it is sufficient for demonstration of the ground current. These currents may create magnetic fields that cause compliance problems. Often, ground plane currents also cause signal integrity problems. Place the tip of the H-field probe over the small ground plane between the switch and the LED of the demo fixture as shown. Rotate the H-field probe around its longest axis as shown. The direction of the current in the ground plane is indicated by the highest pitch of the sound and the most LEDs that are lit. Conclusion: ground planes carry high frequency currents that generate H-field. Minimizing the length of such current paths reduce the emission. Experiment number 6. Locate hidden trace and determine its direction. Non-conductive materials are essentially transparent to the electromagnetic field. A trace on the opposite side of the PC board generates as much electromagnetic emission as if it were located on top. Step 1. Turn the tip of the H-field probe away from the demo fixture and set its level dial to the green LED. Bring the tip of the H-field probe to the clear area on the PCB of the demo fixture as shown. The high pitch of the sound and the lit LEDs indicate that the H-field probe tip is over a hidden trace. Step 2. Rotate the H-field probe around its longest axis as shown. The seam in the tip of the probe indicates the orientation of the probe's sensor. The direction of the current in the hidden trace is indicated by the highest pitch of the sound and the most LEDs that are lit. Conclusion. PC board material is transparent to electromagnetic field. The emission created by hidden traces create compliance problems. As we have shown, the EMC Solutions Kit, brought to you by Hisco, would make an excellent tool for any design or EMC engineer. For more information, please contact your local Hisco representative or visit us online at www.hiscoinc.com/EMC. Thank you for your time.